Whether you're doing van life, you're camping, want to heat your workshop, or even have backup heat for that emergency winter storm, there are a lot of options, and everything has a downside to it. So understanding how the system works is going to help you make an informed decision and better protect you and your family. The first thing I want to talk about is everything that we use that burns has a potential for carbon monoxide, CO, and carbon monoxide is a deadly poisonous gas. So carbon monoxide itself builds up in your body over time. Even small amounts, 5 parts per million, 5 parts of carbon monoxide per million parts of air builds up in our blood over time, and it starts poisoning our body. Now, a lot of people have a carbon monoxide alarm, and that's great, but we need to understand that this alarm is only going to sound off at life-threatening conditions, very high levels. So if you're doing van life, you're out camping, and this is sound off, that means your body has already been poisoned and you're at a very high amount of risk. If we look at the alarm rates on this, it sounds off at 400 parts per million, which is an extreme amount, between 4 and 15 minutes before it alarms. Between 150 parts per million, between 10 to 50 minutes, and its lowest level this is going to sound off at is 70 parts per million over 60 to 240 minutes. 70 parts per million, that's a massive amount of carbon monoxide over a very long period of time. The problem is even breathing something as low as 10 parts per million over time can cause issues in your body, especially for pregnant women, kids, elderly people, or anybody with an illness. That can be an issue. So there's a little bit of a false sense of security with this. I've also seen people test out multiple different ways of heating using one of these, and they test it for an hour or so and just say, oh yeah, it's safe because this didn't go off. It's not necessarily safe. It just means you weren't at life-threatening conditions. What I recommend is everybody have a low-level carbon monoxide monitor. They make these for household applications, but when you're out camping, you're in a workshop, you're doing van life, there's a lot of vibrations, movement, dust, and some of those low-level carbon monoxide monitors aren't going to hold up to the conditions. Just like having a carbon monoxide alarm isn't going to hold up to the conditions of off-roading and camping and van life. So what I recommend is a low-level personal CO monitor. But this low-level monitor is going to sound off when I have a high amounts of parts per million, such as 20 parts per million, 30 parts per million, 10 parts per million. It's going to start giving me a number and start beeping and let me know. Now, I do HVAC, I travel all over the country, and this thing has gone off at some really unexpected conditions and locations and even hotel rooms because the carbon dioxide levels were high, not high enough to set off the alarm, but they were high. People were breathing in these high levels of carbon dioxide. And if we're out camping and burning and heating our space up with a small environment, this is something we want to make sure we have. Now, if you're a tradesperson, I recommend everybody having this, but if you're doing van life, camping, outside, even in a wood workshop, having something like this on you is very important. Keep it close to where your face is going to be, especially if you're camping, put it next to your pillow, and this is going to help protect it, help reduce those risks. Now, also, anything that burns not only has the potential for producing carbon monoxide, a poisonous gas, it also produces water vapor and carbon dioxide. Carbon dioxide being CO2. Now, carbon dioxide is not a poisonous gas, so that's great. But the problem is carbon dioxide building up at high quantities isn't good for us. It causes headaches, for us not to think very well. It's an unhealthy environment. So personally, I like to keep an air quality monitor with me. And there's many different kinds out there, but an air quality monitor is going to give me the CO2 quantities. I use this in my house as I travel and also when I'm camping. I found out even when I was camping in the truck out without using any heat, sometimes the carbon dioxide levels would get high just from me breathing in a very small space. That's a simple solution. I just open the door. But the difference is knowing. If I know about it, I can open the door, get some fresh air in, and we're good to go. We love camping, love the outdoors for that fresh air, not to be rebreathing these high levels of CO2. Now, when we add a fuel burning component to that, we end up with a larger amount of carbon dioxide. These can be unhealthy levels. So being aware that anything that you burn creates carbon dioxide is important. Now, I do recommend anybody in your house, if you're out, if you can't afford it, to have an air quality monitor that's going to give you a number what the CO2 is, because that's keeping it into your mind, and it's a simple thing to do. And once you identify the high CO2 sources, it helps you be healthier in your house or out camping. So now that we understand that, let's look at some of the different options we have for heating. The first we'll talk about is stoves. Now, these stoves are great for cooking because it's almost like they were designed to cook. But when we cook on this stove, we have this open flame, uncontrolled flame coming out. It's open. It has usually your highest amount of carbon monoxide potential, very high amounts of CO2. And also when you're burning the gas, there's other stuff in that gas that's burning other than just the propane itself. And we're breathing all that in. So anytime that you're cooking, you want to make sure you open your doors, have some fresh air, make sure that you're getting air circulation. Even if you're cooking in your house, make sure you're running a vent hood where you're exhausting that outside, because all that stuff inside we're breathing, we don't want to breathe that. Now, you definitely do not want to use any of these things for cooking for heat, because that high quantity, even when I put a pan on here, the temperature of that pan changes the flame and changes how much carbon dioxide, carbon monoxide it's producing just by putting that pan on there. So we never want to use this for a heat source. It's good for cooking, but we still need to understand, hey, have some fresh air, have some ventilation. The next option that we see is these little buddy heaters. Now, these are great. They have some great options, but one thing is people assume that they're a catalytic heater, and they're not. They do burn across this type of material here, which helps the flame burn very clean, very even, and it's an improvement, but it's not a catalytic heater. These still produce a very small amount of CO. Now, what I can do is I can check this with my meter. I can show you that it happens. It's a very small amount, and if you have good ventilation, it's nothing to worry about. But the thing is, just putting them in and thinking that they don't produce CO is an issue. They do produce carbon monoxide, very small amounts, but it is something to think about. The other thing is, as we're burning any type of fuel, we're also using up oxygen. So the oxygen level drops. At once upon a time, these didn't have any safeties in them. Now they've added low oxygen alarms in here. But because they have low oxygen alarms, people think it's protecting them from carbon monoxide, and it's not. It's protecting you from low oxygen. It has nothing to do about carbon monoxide. So even though these will shut off automatically from low oxygen, they're not protecting you from low amounts of carbon monoxide or high levels of carbon dioxide. So these are something you need to be considered about. It doesn't mean that they're bad. It just means you need to be thinking about the whole entire picture. And you also got to keep these clean. As dust builds up on here, it changes how these burn. Also, when these propane starts getting low, that burns differently, and you also have a higher risk of putting out carbon monoxide. But as long as you have a meter, an alarm, something with you, you can understand that, hey, the levels are getting high, we can shut it off, we can open the tent, open the window, hey, we're good to go. It's just simply the difference between knowing and understanding the limitations. Now, with something like this, you got to make sure the base is on there, because these can fall over. Same thing as this, making sure nothing's too close so it doesn't catch on fire. But also, anything that we burn in here, any of the impurities are also burning out, so that does end up in the air, and something like an air quality monitor can help you identify that pretty quickly. So it is an option. It's definitely better than the cooking side of it, but understand there is some limitations, and it may or may not be the best option for you. Another thing that we have is catalytic heaters, but these catalytic heaters have no safety. There's no way of having a safety in it. Because they're a catalytic heater, they don't produce any carbon monoxide at all if they're working correctly. Now, if they get dirty and dusted, they still have that potential, but they still create CO2 and water vapor. So they are going to have a lot of water vapor in the air. You see condensation just like you will with this, but these don't produce carbon monoxide, but they will reduce the amount of oxygen. Like these have a low oxygen shutoff, this does not. And that's one of the reasons they discontinued this. But it's a very simple thing, and what I do is I have a low oxygen monitor. I also do mine exploration, so having these meters comes in handy there as well. But having a low oxygen alarm with this type of heater, I know when the oxygen level drops down, we have an issue. Now, one time I didn't have this with me, ended up having a low oxygen situation, had extreme headaches, I couldn't think very well. It was quite a scary situation. So from now on, I make sure that when I'm using this heater, I have my low level oxygen alarm with me. Now, most of the time that's not necessary. If you have your CO monitor or your air quality monitor, it's going to be covered. But if you're using a true catalytic heater, and there's many different types, you do want to make sure you have a low oxygen monitor with you so you can protect yourself. Now, one of the things we hear a lot about is using candles and also putting that clay pot on top of it. So a few things we need to understand is, as we're burning a candle, we are creating carbon dioxide, carbon monoxide, and water vapor. So all those same things still apply, even though it's a wax. But some of the waxes that are used are an indoor air quality issue. On top of the CO2 and everything else, it has some carcinogenics in there, so we're going to be careful of what type of wax that you use. I don't recommend using candles at all, but I found out that I cannot win that argument with my wife, so it's just one of the things we have to deal with. But understand that this has a BTU content. As we're burning this candle, it has so much heat content built into it. Now, as we light this, most of that heat's traveling up through what we call natural convection. So here, a lot of people talk about putting a clay pot on top of it with the hole, and it allows it to heat up this pot. They say it heats better. there's still only so much heat available in this candle. The difference is we're heating up this pot right here, and that pot keeps the heat down lower, keeps the radiant heat down lower, but it doesn't make any more heat. It just simply controls the heat in one spot, but once the heat transfer is done, once the temperature equalization happens, we're really done. But it is an option, something you can use. It's just understanding the limitations and what's good for you. Now, another option is electric heat. Electric heat works great if you're in a house and your heat pump's not keeping up, or your gas furnace shuts down, or your gas issue. Having electric heater is a great option. Now, when you're out camping, it's a little bit more difficult. Some people do use battery systems, and it's enough to handle the electric heat needs, but you're talking about a lot of drain on those batteries. So some people use a little generator. They put a generator outside, they hook up their electric heater, and that's how they're able to heat. Now, the thing is, you got to think about carbon monoxide if you're using a generator. You want that generator far enough away that it's not going to get carbon monoxide and carbon dioxide, all that stuff, into your van. You want to make sure you keep it far enough away that you're okay. Again, battery is ideal, but then the weight and the cost of battery is going to be an issue. The other thing is, if you're using that generator at altitude, it's going to have a reduced wattage output. So if you're up in the mountains at elevation, you're going to have a lot less wattage and a lot less heat that generator is going to be able to put out. So up in altitude, you may have an issue with that generator can't keep up with the heat load of your electric heater. And the newer thing is we have our diesel heaters. Now, diesel heaters are becoming very, very popular right now. I have both of them, and there's good and bad things about diesel heaters as well. The first thing to understand about a diesel heater, it's an oil furnace. Number two, heating oil and diesel is really the same thing. You're just paying road tax with diesel. But this has a heat exchanger in it, just like your heater, just like your furnace has. It has a heat exchanger, and we're going to be burning diesel inside this heat exchanger and removing air on the outside the heat exchanger, which sounds great, and it is, but we got to understand the risk inside this heat exchanger, especially since these are fairly cheap made with cheap materials. The heat exchanger can crack, some of the seals in here can crack, and you can still have carbon monoxide poisoning. So what's great about this is it's pulling air from the cabin into that same cabin, and it's keeping the combustion air, the air that we're burning, separate. It's pulling air from outside in, we're burning it, and then we're exhausting the air back outside. So it's keeping the air inside, outside, completely separate. That solves the water vapor and condensation issue. That solves the carbon dioxide issue. It solves the carbon monoxide issue. It's really a great way to heat, but we still have to understand there's risk involved. This heat exchanger can crack. How well sealed is the van? Is carbon dioxide out from outside going to seep back inside? So you still need to have your low-level carbon monoxide monitor. But if you install this correctly, it does solve a lot of other issues. One of the problems is these things put out so much heat, they're typically too big for a lot of applications. You end up with them overheating, having to cycle them on and off. It's also important to note that these exhausts must be ran correctly. It must follow the proper procedure so that this doesn't overheat what it's touching. And they do put out so much heat, the heat temperature is so high, you got to be sure you're protecting your duct so it's not catching anything on fire. The other thing is, if you shut these off, they have to have a shutdown sequence. You can't just kill power to them. You have to go through the shutdown sequence so it can burn out all the fuel that's inside of here. There's a lot of different Facebook groups, so they're called Chinese parking heaters or Chinese diesel heaters, and there's a lot of good with them, but there's also a lot of bad. And just because they work like a little furnace doesn't mean that you're out of the woods from your carbon monoxide. You still need to have your low-level monitor. Now, these work great when they're installed correctly, but sometimes people install these kits outside. The problem is they're pulling air from outside, heating it, and putting it in. Now, you solve the issue of it being too big, but the problem with pulling air from outside is you're also pulling air right at the same area your exhaust is at. So if you're pulling that exhaust, that carbon monoxide is being exhausted right here in the same area, pulled right into the heater, and being that heat's going right inside of the tent or the camper, and now you have a big issue. So understanding that is important. Now, one of the big popular options now is these self-contained diesel heaters. This is essentially this same component right here installed in the bottom. We put the fuel tank on top, and they work pretty good, especially in a workshop, because you're pulling air from the workshop, putting the air back into the workshop. You have your exhaust pipes, so you're exhausting it outside, and it works pretty good. The problem that we're having is I'm seeing campers and van life people hook this up outside of the camper and turn it on and run it. The problem with that is very similar. We're exhausting our air outside, and it's pulling that air right into the same unit, and now we're putting all that carbon monoxide, all of the indoor air quality associated with diesel, we're putting all that inside the camper. It's a huge risk. And I've seen somebody had a carbon monoxide alarm go off. Well, if this alarm's going off, that's a danger level. Now, if you have your low-level monitor, this is what you need to be looking at. But if we think about that, we need to be able to reduce the risk. And there's several options. You can modify this box where your return air is being pulled from someplace else. Add another duct so you're pulling air in from farther away than your exhaust. But understanding that this exhaust coming out of here can be pulled right back in is a big issue. And the other problem with Vanlife stuff, sometimes they'll put this with the air intake for the combustion side. They won't have the air come from outside. They'll be using air from inside the cabin into this. But what it does, it literally burns air from inside the cabin and exhausts that outside. Well, as you take air from inside the cabin and push that air outside, you end up with depressurizing the cabin, and air has to come in to make that up. So air from outside is being drawn back in through your doors, cracks, crevices, whatever, and you have a higher issue of being able to pull carbon monoxide back into the unit. So even if this is installed inside your van and you don't hook up the air intake, you could literally be depressurizing your van, pulling carbon monoxide from outside in. So the next question people ask is carbon monoxide going to rise up or is it going to fall down? And the answer is yes. Below 32 degrees, carbon monoxide is heavier, so the carbon monoxide is going to come down. So if you're out camping below 32 degrees, that carbon monoxide is going to be down low, right next to where your heater is, and you're more likely to be pulling that right inside your van or your tent. Now, if it's above 32 degrees, it is slightly positive. So the carbon dioxide is going to naturally rise up, not fast, very easily, very softly, and naturally rise up. So understanding your risk, understanding how carbon dioxide works, it will be heavier below 32 degrees. Above 32 degrees, it's slightly about 3% buoyant. So it's going to slowly travel up. So understanding we don't want to be using these diesel heaters incorrectly where we're catching things on fire and where we're pulling carbon monoxide into our vans. We want to make sure we're healthy, we're safe, we're good. The one thing I left out was kerosene heaters. I don't have an example of a kerosene heater, but it goes back to that same rule. Make sure you have a low-level CO monitor, and if you can, have a CO2 detector in there too, so you're seeing the CO2 levels. And then, of course, fireplaces, that's a whole nother situation. But fireplaces, you want to make sure that you have plenty of air coming in for that fireplace to burn so that it can exhaust it back out. What happens with the fireplaces, even those little rocket heaters, is you end up with the van that's sealed really tight, and it's using air from the van to travel up and out, and you end up with a negative pressure or even exhaust. Some of that carbon monoxide comes back into the van. You get smoke going into the van, and it's an issue. Even if you don't have smoke coming back into the van, you can still have CO, carbon monoxide, being pulled back in, as well as CO2, carbon dioxide, being pulled back in. So again, I'm not saying any of these are bad. Well, okay, well, this is bad for heating, but understanding your limitations, that none of these are perfect, and you have to go through your installation. You got to understand what your budget is, and at least at the very minimum have a low-level CO monitor and hopefully a CO2 monitor so you're seeing the air quality. It's going to make everything go so much better, and these simple little things can save lives. Unfortunately, the older models of these didn't have oxygen shutoffs in them. So people literally died before they started mandating you had to have an oxygen shutoff. And more people have to die from carbon monoxide before they start saying, hey, you could have carbon monoxide alarms, carbon monoxide detectors. And unfortunately, people have already been dying from the diesel heaters with cracked heat exchangers or pulling carbon dioxide and carbon monoxide from outside where these are burning inside. So unfortunately, people are dying about this because they wanted to save a little bit of money. I want to save money too, but let's do so in a safe method where we understand the risk involved, and now you can do whatever you want to do. It's your life, it's your risk, you can take it on, but these little things here, understanding it, now you understand the risk, and you can make the decision that's going to be best for you. And hopefully you stay safe, you explore this beautiful world that we live in, and make sure you help somebody else out, and most importantly, never stop learning.